Hello everyone and welcome back to the channel. Today we will be doing questions on trigonometry class 10. So if you are interested in these questions, grab your book and pen and let's begin with the questions. So the first question is cosec theta minus cot theta the whole square is 1 minus cos theta upon 1 plus cos theta. Okay, as we know, if you are going to be doing questions based on trigonometry, we should be very much aware about the trigonometric formulas or identities. So the first one is cos square theta plus sin square theta is 1. Sec square theta minus tan square theta is also 1. And cosec square theta minus cot square theta is 1. Now this can be rearranged as sin square theta is 1 minus cos square theta, or otherwise cos square theta is 1 minus sin square theta, and same way you can rearrange this as sec square theta is 1 plus tan square theta and tan square theta is sec square theta minus 1, and same way. So from one identity we actually have three. Okay, in three different forms you can write it, that's what I mean. Okay, so let's begin with this question, and for this ones, when we are doing questions on trigonometry or any other proof that, normally we should begin with a side which has more terms, so it becomes easier to prove. So over here this one is having more terms. Let's begin with the right hand side. So this is 1 minus cos theta upon 1 plus cos theta. Let's rationalize, like it's similar to rationalizing the denominator. When we had 2 plus root 3, we would multiply and divide with 2 minus root 3. Same way over here, since we have 1 plus cos theta, let us multiply and divide with 1 minus cos theta. So multiply with 1 minus cos theta and divide with 1 minus cos theta. Now what is the denominator? It is a plus b, a minus b, which becomes a square minus b square. And what's the numerator? 1 minus cos theta whole square. Now as you can see, left hand side is having whole square, so we will not simplify this, leave it as it is. And also this is 1 minus cos square theta is from here, 1 minus cos square theta is sin square theta. Okay, so we have that here. Okay, now let's combine the square, and what do we have? We have 1 upon sin theta minus cos theta upon sin theta. So that is cosec theta minus cot theta whole square, and that's the left hand side. Okay, so in this question the left hand side has more terms, so we'll start with the left hand side. And normally in trigonometry, whenever you are supposed to prove a thing and you have 1 plus sin theta or sin a over here, 1 minus sin a, 1 plus cos a or 1 minus cos a, then we will do as we did in the previous question, similar to rationalizing. But over here, because there are so many terms and we can take LCM because the denominator is different, we'll do that. So let's take LCM. Start with the left hand side. So in this case, what we have done is, like suppose if you have a term which says it is 3 by 5 and 7 by 2, and how would you take LCM? In that same way we have taken LCM. Okay, you would multiply and divide this by 2, multiply and divide this by 5. That's what we have done. Over here there is cos a, and here we don't have cos a, so we multiplied and divided by cos a. Over here 1 plus sin a, and that's why we have this as the denominator. Now over here we'll have to simplify this whole square identity will apply, because here we don't have any square terms, or we don't have a whole square. 1 plus 2 sin a plus sin square a. So we have applied the identity a square plus 2ab plus b square, and denominator for now we'll leave it as it is. Now we see this is cos square a plus sin square a, our first identity. which is 1. So we put this as 1, and so we have 1 plus 2 sin A, which is 2 plus 2 sin A and if we take 2 common from here, that's the numerator, we have 1 plus sin A which gets cancelled with the denominator, and it is 2 upon cos A, and we know 1 upon cos A is sec A. That brings us to the right hand side. This is our next question. In here we have tan and cot, over here sec and cosec theta. Okay, now what happens is, normally in trigonometry, if you have all or many different trigonometric ratios, you can convert everything to sin and cos. Now on converting to sin and cos, because we are doing the basics of trigonometry, you will always come to the right hand side, or if you have started with the left hand side. But sometimes it may become lengthy, but anyways you will come to the result. Over here also you can convert to sin and cos, but as you can see, the left hand side only has tan and cot. Will convert one of them to the other ratio, like we can convert cot theta to tan theta and then come to the result. Afterwards we can convert it to sin theta and cos theta, which may bring us to sec and cosec. So let's do by converting cot to tan. So we know that cot theta is 1 upon tan theta. Let's do that. So the first term is to be simplified here. You see the denominator. So taking LCM, like earlier one, over here it is 1. So multiply, divide by tan theta. So now over here we have, in denominator we have tan theta. And this was in numerator's denominator, it will come down. Let's take this here. So this is tan square theta upon tan theta minus 1. Now again the same thing, you see, like, okay, before that it is 1 minus tan theta and tan theta minus 1. So if we take minus 1 common from here, from the second bracket over here, it becomes tan theta minus 1. So this part of the denominator is same. So when we are taking LCM, we simply need to multiply the first one with tan theta to have the same denominator. So let's do that. First one with tan theta. So this becomes tan cube theta. Multiplying by tan theta, it becomes tan cube theta. This will remain the same. And denominator is tan theta into tan theta minus 1. This term is a cube minus b cube. Let's apply the identity. So we have a as tan theta and b as 1. This is tan square theta plus tan theta plus 1. So tan theta minus 1 will get cancelled because it's a, okay. Now you see, these terms are tan theta and this is also tan theta. We don't want any term in the denominator, or rather we want one. So let's separate this. So we have tan square theta upon tan theta plus tan theta upon tan theta and 1 upon tan theta. So this is tan theta plus 1 plus cot theta. So whenever you are doing questions of prove that, or especially for trigonometry, keep an eye on the right hand side. So we see that 1 is there, so leave it as it is and solve only this much, tan plus cot. Now right hand side doesn't have tan cot, so I am converting tan to sin theta upon cos theta, and cot theta is cos theta upon sin theta. Now once again we come to a situation where we will have to take LCM now. So let's take the LCM. It is sin square theta plus cos square theta upon sin theta cos theta. Now what is sin square theta plus cos square theta? It is 1. So this becomes 1 upon sin theta cos theta. 1 upon sin theta is cosec theta and 1 upon cos theta is sec theta, and that's what our right hand side is. So as we discussed, this question can also be done in the other way. You can convert this to sin and cos and solve it. In this question, because the left hand side is having sec a and the right hand side is having sin and cos, we will start with the left hand side and convert sec to cos. Now both the sides are having almost same number of terms, so you can start with either of the side. So this is sec is 1 upon cos a. So let's take LCM. This becomes cos a plus 1 upon cos a, and denominator is 1 upon cos a. So both this numerator's denominator and denominator's denominator will get cancelled. We have cos a plus 1, otherwise 1 plus cos a. That's the left hand side. Now as you can see, we have 1 minus cos a in the denominator. So you can simply rationalize this. There is nothing in the denominator, means there is 1. So we can multiply and divide with 1 minus cos a we are dividing, and we are going to multiply with the same. So according to our identity, sin square a plus cos square a is equal to 1. We have 1 minus cos square a. First I have applied a plus b, a minus b, which is a square minus b square. So what is 1 minus cos square a? Sin square a. So we have sin square a upon 1 minus, so we have sin square a upon 1 minus cos a. That's the right hand side. And if for at all after this you're not sure what to do, then we can start with the right hand side. This is the other method. Up till here it is same. So if we start with the right hand side, we see that left hand side is only having cos a. There is no sin term. So from here write sin square a value, which is 1 minus cos square a. And 1 minus cos square a can be written as 1 square minus cos square a. So a square minus b square, a minus b, a plus b. So 1 minus cos a gets cancelled, and we have 1 plus cos a. Sorry, over here 1 plus cos a. The left hand side and the right hand side both are equal. So either way you can prove it. All the questions of this exercise are very important, but question number 5 is the most important, you can say, because there are various ways of doing it, and if the question asks use this method only, then you have to do in that particular way. If the question doesn't mention use this, then it can be done in another way. Let's see that. So that means the question is given like this. So what you can do is, you can use our simple rationalizing the denominator kind of thing. So what we'll do is, we will multiply and divide with cos a plus sin a plus 1. Now you can simply expand, like cos a you multiply with each of these terms, minus sin a with each of these terms, and 1 with each of the terms. Same for the denominator. Or else, if you can rearrange the terms, as you can see, cos a plus 1 and cos a plus 1 is there, and we have minus sin a. The other term has cos a plus 1 and plus sin a. The denominator is cos a plus sin a minus 1 and cos a plus sin a plus 1. So I think you have understood now that we are going to apply a minus b and a plus b in both the numerator and denominator. Only thing are a and b are different terms. So now it is cos a plus 1 is a and b is sin a. Same way in the denominator, cos a plus sin a is a and 1 is b. So I have applied a square minus b square at both the places. Now expand a plus b whole square formula. So as we know, a plus b whole square is a square plus 2ab plus b square. We have applied that here in the numerator and denominator. Okay, now let's see which trigonometric identities we can apply. 1 minus sine square a is cos square a. So we are going to write this as cos square a. Also, we know that cos square a plus sine square a is 1. So we have 1 plus 2 cos a sine a minus 1. So this is going to get cancelled. Now go back to the numerator. You see cos square a plus cos square a, that's obviously 2 cos square a, and plus what else is there? 2 cos a. Denominator is 2 cos a sine a. So if we take 2 cos a common from here, we have cos a plus 1. And so this gets cancelled. Now that didn't give us the right hand side, but if you see and you separate these terms, that is, we write it as cos a plus 1 upon sine a, which can be written as cos a upon sine a plus 1 upon sine a. What does cos a upon sine a become? Cot a. And what is 1 upon sine a? Cosec a. And so that's what your right hand side is. So this is another way of doing this question. If it doesn't say use the identity cosec square a is 1 plus cot square a, then you can do this. I hope you have understood the sum. Trigonometry is a topic which you have to practice again and again. The more you practice, you will get better at it, and it is a very important topic in mathematics. See that you make yourself well versed with it.